Hello everybody and welcome to Trigonometry once again. Today we'll be dealing with chapter 4.3, which is the following. We'll be dealing with equivalent trigonometric expressions. First I'll talk a little bit, or actually a lot, about trigonometric identities, and then we'll actually get on to how to evaluate trigonometric expressions. Okay, so here is our thought on trigonometric identities. Last year, you should have begun learning about them, but honestly, this year, your knowledge will be expanded by at least like tenfold. So at first, we're going to be learning about these identities. Here, I have listed 6 out of the 12, but don't worry, I'll be going over all of them. So essentially, these identities can be easily derived using the unit circle and also right angle triangles. I know, trig and right angle triangles, you would have never guessed. So, for example, some of them you might remember from last year. You might not remember the exact form, or you might have not seen these exact forms, but you should be able to recall them. For example, let's look at the graph, or let's imagine a graph of sine of x and cosine of x. So, you should remember that sine of x is essentially the graph of cos of x, horizontally translated like 90 degrees, right? So using this knowledge, we can actually write that as sine of x is equals to cosine of x minus 90 degrees. Since we're dealing with radians, I just rewrote it using radians, which is that form over there. So next, I multiplied the cosine expression by -1, which reflected it in the y-axis. And since it is symmetrical in the y-axis, our graph actually doesn't change. However, we could now rewrite the equation that we got as sine of x is equals to cos pi over 2 minus x. That is the exact form of the trigonometric identity we learned today. With that being said, I will show you how to use the unit circle and right angle triangles to derive the rest of the identities and tell you how to remember them a lot more easily. Okay, so let's get started. First of all, I've put all of the trigonometric identities that were put into the textbook for this chapter over onto here so we could look at them all. Then I made a unit circle so we could start actually deriving them. So first, I just want to describe what happened here. I drew a right angle triangle with their angle x. Again, it's a unit circle, so the radius is 1. So we have our key values of 1, 0, 0, 1, -1, 0, and 0, -1. So let's look at our first identity, which is sine x is equals to cos pi over 2 minus x. So for here, what we need to really talk about is this portion here at first. So what does pi over 2 minus x actually mean? So I've labeled all our different parts on the unit circle. This right here is pi over 2. So from here, we're saying that pi over 2 is our minus x is our new angle. Since this is x, we could actually make a new triangle or a new angle and see that this is x, right? So pi over 2 minus x would actually make us have this new angle over here, which is pi over 2 minus x. This is our new angle and our new triangle at that. We could again just make it, I'm going to try to make it a little bit more visually appealing so you actually could understand what's happening. There you go. This is our new angle, our new triangle. So from here, let's talk about our first identity. Our first identity is talking about sine x. So sine x, as we know, is actually equal to our y value, right? Because it's opposite over our hypotenuse, which is 1, therefore sine x is equals to y. Our cos x is always equals to our x values. So for this triangle, what we actually ended up doing is looking at this area over here. Sorry, let's highlight it. Our triangle was this, right? Y and x we're all good here. Now I want you to look at this triangle over here, which you should understand is identical to this triangle over here, just because they are part of the same rectangle. So this is y and this is x, therefore they're the same. But let's look at this one, because personally I find it easier. So over here, our angle was x, we had a 90-degree angle, and we had the same side. With that, we have found angle, side, angle that are the same. Therefore, our two triangles are identical. That means this triangle here is also identical to this triangle here. It was just transformed. So let's talk about how it was transformed. First of all, let's look at what happened to the short side. The short side is now at the bottom, right? So this is our y value, and it became our new x value. So I wrote that as x2. Our old x value now got transformed into our vertical value, which means this is now y2. Therefore, this point over here is now yx, and this used to be x and y. So let's discuss what these values mean for us. So again, looking at the first identity, it has told us that cos pi over 2 minus x should equal to this. Let's see if that's true. So what is our x value? Our x value is now our old y value, so that is y, and our hypotenuse is still 1. Therefore, cos pi over 2 minus x is actually just equal to y. As you can see here, these values are the same. Therefore, we have proven that the identity is correct. Now, we could continue going with this idea. Okay, now let's look at tan. So tan is actually rather easy. Tan, as we should already know, is actually just equals to our opposite over adjacent, which is y over x in our case, right? So what it's telling us here is that for the angle pi over 2 minus x, cotangent should have the same value. Cotangent, as we know, is the inverse of the tangent function. So for example, we could say that let's write that, cot of x is equals to 1 over tan of x. What is tan of x in this scenario? Tan of x is actually equals to y over x. Sorry, x over y. I wrote that wrong. X over y. So the inverse of this would be y over x. As you can see, these two values are again the same. Therefore, our second identity has been proven true. Lastly, we're actually talking about cosecant and secant, which is the inverse of the sine and the cosine functions, respectively. However, this one is genuinely just super simple. All we're saying over here is that, hey, we found out that y over here is the same as the y we would have gotten over here. I don't know where it went, sorry about that. So, if we took 1 over sine of x, that would be the same as taking 1 over cos pi over 2 minus x, right? Since they were getting the same value. So cosecant of x is equals to secant of pi over 2 minus x. Again, now we got these two values. The other three are a little bit more complicated, but actually not really. The way that you actually realize what they mean is by going through the same procedure. So let's just delete everything we don't need. I'll leave those to be. So let's look. The first one's talking about how cos of x is equal to sine pi over 2 minus x. Okay, so it's saying that, so we know cos of x is equals to our x value. Sine pi over 2 minus x would equal to our new values. So that's sine pi over 2 minus x is equals to x over 1, which is again x, therefore our identity is true. The second one is cotangent of x is equals to tangent of pi over 2 minus x. So again, it's saying that these values are the reciprocal of that, which we know is true. Therefore, again, we proved it. Lastly, it's saying that the secant of x equals to the cosecant of pi over 2 minus x. So again, they just took the inverse of these two numbers. We know that's true. So then they took the inverse of these two functions, which gave them secant and cosecant. And that was it for that. Next, what we have is sine of x plus pi over 2. So sine of x plus pi over 2 is the same as taking this angle and actually moving it by pi, which you should know is 90 degrees. So now we have this new angle over here. What this angle here is, the angle here can easily be found by the following. Since we moved everything by 90 degrees, or pi over 2, this over here is now x. If this is x, and this is pi over 2, this angle here, again pi over 2 minus x, but since we have pi over here, it's actually pi minus x. With that information, our life is again super simple. Okay, so let's actually analyze what happened here. Our y value has been moved down, right? So this is our y value, but as you can see, it's approaching -1, therefore it is -1. Our x value got moved up to our vertical side, and it's still approaching a positive number, therefore it is positive x. So now our new point over here is -y and x. Now let's look at the first identity on this side. So sine x plus pi over 2 is equals to cos of x. We know what cos of x equals to. That equals to x. Let's see if sine x plus pi over 2 equals the same thing. So sine is equals to the opposite side. So that's x over 1, which is equals to x. Therefore, that identity is correct. Now, what it's saying over here is that tangent of this is equals to the negative of this. Is that true? Let's see. We would have x over -y, which is negative x over y, and this is x over y. Therefore, yes, that is true. Next, we have our secant, cosecant, and secant. Again, just taking the inverse of whatever we got. That is correct. Therefore, we're good with that. Next, we have our cosine. So cosine is said to be equal to negative sine of x. So sine of x, I wrote it before, but I'll rewrite it. Sine of x is actually equal to our y value. Over here, cos of x plus pi over 2 is equals to cos x plus pi over 2 is equals to our adjacent, which is -y. -y and y are the same value. One of them just was multiplied by -1. So in this scenario, they said we could just simplify or multiply this side by -1 rather than that one. But we've also proven that negative cos x plus pi over 2 is equal to sine over x. So that's good. Cotangent and tangent, again, they just took these values and then they found out that they're the reciprocals of one another, but one of them is negative, the other one's positive. Therefore, that's the identity. As you can see, these were just multiplied by -1 on one side, and you would get the exact same thing. Lastly, the secant and the cosecant. Again, what we have here is just the inverse of what we were getting before. But let's analyze it a little bit better. So for example here, the cosecant of x is actually 1 over the sine of x, which we know is y, which is equals to 1 over y. The secant of x plus pi over 2 is equals to 1 over cos x plus pi over 2, which we have over here, which means it's -1 over y. Since this is negative and this was positive, we are safe to say that these are identical, just this one was multiplied by -1, therefore that's the identity we get here. Hopefully I helped you clear up some things about how we were getting these answers, but the important takeaway here is that instead of trying to make this chart, you just need to remember how these x and y values change. So honestly, you just have to remember x, y, y, x, and -yx for 0, pi over 2, minus x, and pi over 2 plus x. If you know those three values, you could determine all 12 of these identities in a matter of seconds, again, just by doing what the ratios tell you to do, so opposite or hypotenuse over adjacent, depending on which trigonometric ratio you're working with. So that's it for this part. So I hope you enjoyed that little demonstration, but let's get going with the rest of the content. Okay, so using the identities we evaluated, or the identities we found, we can now evaluate certain trigonometric expressions. These certain expressions are the ones that are actually using the equivalent values or the identities we just found out. So for example, let's say we are given that sine pi over 7 is equal to the following number. It's asking us to evaluate the two other trigonometric expressions that we were given. So here I actually solved part 1 for you. You could do part 2 on yourself. So cos pi over 14 lies in the first quadrant. The way you would know this is whether or not it is between the values of pi over 2 and 0. Since it is smaller than 7 pi over 14, which would be pi over 2, it is in the first quadrant. Since it is in the first quadrant, we can actually express this as a difference between pi over 2 and an angle A. Again, we figured out why that works in the demonstration, so now we're just applying the knowledge. So I wrote pi over 5 pi over 14 is equals to pi over 2 minus A. Rewriting pi over 2 is 7 pi over 14. Then I isolated A on one side of the equation, and so we got -2 pi over 14 is equals to -A. So A is equals to 2 pi over 14. Then I didn't do the step explicitly here, but you could again reduce this into A is equals to pi over 7. So now what we found is that cos 5 pi over 14 is actually equals to cos pi over 2 minus pi over 7, which, using our identities, we could say is actually equals to sine of pi over 7. Because again, this was our x value, right? And we said that this is sine of x. Therefore, we found our value. We were given what sine pi over 7 equals to. Hence, cos 5 pi over 14 gives us the exact same value. You can try the second question by yourself. It will follow the exact same procedure I just did. And for that reason, I will give it to you. The only difference here for 2 is a little hint. You should remember what quadrant that lies in. Because again, if we're dealing with cosine and it goes outside the bounds of the first quadrant, cosine could become negative. And if cosine is negative, that means our answer should be negative. With that in mind, here's the homework for today. Today's lesson seems a little bit short because honestly, it's again a lot of just applications and dwelling yourself deeper into understanding what these concepts mean. There's not much I can do to describe how to use them. It's just practice, practice, and more practice. So part A, I'll just verbally explain. Actually, no, I think it shows you. Part A is just evaluating the expressions like I showed you in our example. All of them are very similar. This one, you were now being described how to do a different expression, but it's almost pushing you through on how to do it, so nothing here is extremely complicated. That is why I assigned all of part A. You don't have to do all of it, but it's going to be good practice. Then for part B, I've assigned I think 12 and 14, or 11 and 14. Again, they're just very similar to what we did. Then for questions 15 to 19, you're actually going to be investigating the rest of the unit circle. You could follow the exact same procedure I did, but now for quadrant 3 and 4, that's essentially what this is. Then I've also assigned question 22, which is supposed to test all of your knowledge from this particular subchapter. Again, if you have any questions, feel free to contact me. This chapter, I would say, personally, from my experience, wasn't that necessary to remember fully, because personally I don't remember much of it at all, but it is a really good foundation for the next chapter we'll be doing, which is chapter 4.4. Then also in our class we learned about another type of trigonometric functions and or ratios, which is not discussed in your book, but I will be giving you a couple of examples with the next lesson. So stay tuned for that. Otherwise, thank you for listening. I hope you have a wonderful day.